Right. Welcome back for those who came back. I'm going to carry on this introduction with a lot more technical details because right now I'm going to explain you how to integrate navigation inside your game. So I'm going to show you some secrets so that you can integrate as fast as possible. Let's start with stating exactly the problem we want to solve. Okay, you have your own engine, or you use maybe a third-party engine that we do not support directly, that is not Unreal Engine 3. The problem is you want to use navigation because it's a good software and it provides the services that you want for your game. But of course, integrating external technology is intimidating. It's a lot of work. It requires you a long time to integrate and even more time to master. We designed navigation to be easy and friendly to integrate. So today, I'm going to show you how easy actually it is to integrate. You are going to see that in 30 minutes, you can integrate navigation quite easily, step by step. So the secret for a successful integration is the Navigation Lab. Of course, the Navigation Lab comes for free with navigation. We provide you the API, we provide you the source code, and this awesome, awesome tool. So let's see what to do when we get started. Okay? You get the middleware, and you need to link the libraries, and there's two things that you need to do. You need to create the base system, and you need to create your first world. And I'll tell you what, we are going to do some code today. So if I take my system, I have a new class. This is my new game. This is my game. It's a very, very simple game. And as you can see, creating the base system is very easy. I only create a base system, gave it my license key that we give you, and you initialize it with your configuration so you can set parameters for the memory usage, for instance, and that's it. You're done. Once you have your base system, the next step is actually you need to define your game space. I told you that, for instance, Unreal Engine is left-handed, whereas navigation is right-handed. Your game can be any space you want. You have to tell us which space your game is on. So you can provide us with a coordinate system. And then the first thing you need is to create a world. And finally, and the most important thing in your first line of code is to create the Visual Debugger connection. Because this will save you a lot of time in the long run. And that's it. You are done with the initial setup for your game. That's all you need to start. So now, the next thing, once you have this done inside your game, is actually using the Visual Debugger. The Visual Debugger enables you to actually draw anything you want from your game inside the tool. So if you are programmers mostly, right? So usually when you have some problems, sometimes you do printf, right, to print messages. What if I tell you you can say draw line, or draw cube, or draw cylinder, directly from your game inside the tool? Let me give you an example of this. So say in my game, I want to draw a line, or I want to maybe to draw a cylinder, or maybe I want to draw a box, or maybe some text. Let's see together what the results looks like. So I'm going to compile this and run it. And while it is compiling, I'm going to launch my tool. It's already up and running. I'm doing it's going to, yes, I want to build. So we provide you support for Visual Studio 2008, 2010, 2011, 2012, I think, also. So you have any Visual Studio you want to use. So, OK. So while it is compiling, linking, it always takes a little bit of time, right? So my game is not very interesting, right? Yes, nothing, no visuals or whatever. But when I look at the output, I know that navigation is active, and I know that the visual debugger is active. So if I connect to, now if I connect to my game, connect like this, I can see that all the information I sent from the game is sent to Visual Debugger, and then I can draw anything I want. So not only can you draw navigation information, but you can draw any debugging information you want. This will save you a lot of time. So I'm not very good at animation, so I just did some basic animations. So next step, once you have the Visual Debugger running, is actually loading data. This is what you want. You want some Nav Mesh, and you want to load that inside your game. So the first thing to do when you do that is probably just to get an artist, ask him for a level geometry, one of your geometry, whatever, and drag and drop it inside the navigation lab. So this way you can check your geometry, that it's the right geometry, and directly inside the tool, if you want, you can specify all the parameters you want for the generation and generate. And now you can see directly inside the tool the Nav Mesh, right? You can see everything that has been generated. So this is a very cheap way. It's easy to do. You can take any artist, it will give you the asset, and then you can generate in 5 seconds. And this, the good thing is, you can save this information inside a file. So now, I have, if I go here, I have a file that contains my Nav Mesh. So once you have a file with your Nav Mesh, what you want is to load it inside your game. So what I'm going to do is simply create my first level, a new class, my level, my game level, and I'm going to say, this game level needs to load my nav data, as a file. Just open it and load it, and create the nav data out of my file. And this nav mesh, I'm going to add it to my world. That's it. That's all you need to do. And once you have done that, your nav mesh is loaded and ready to be used. So if I just show you how it works, you can see now I'm just going to rebuild with this example and clear this because I don't need that anymore. I'm just going to wait for a second. It's always a long time, running, linking. That's not very fun, I'm sorry. So now that my game is running and linking, it has loaded my data, and I'm going to check if my data is correctly loaded, so I'm going to connect. And it will ask me where the data has been generated first, so I'm going to give it the path, like this. And now I can see that my game is running, and my data is loaded. So that's really good, because if I go to the statistics, I can find out how many data I have loaded, and what the memory use for that data. Very useful, very, very useful information, right? So now that I have data, I want to pathfind. I want to go from point A to point B. So maybe the first thing I want to do is probably test a pathfind solution directly inside the tool. So I'm going to do this, like this. I'm going to define a point A, I'm going to define a point B. And I'm going to say, this is point A, point B. And check that it works, right? So I've defined 2 points. And as you can see, I can pathfind from point A to point B. But this is inside the tool. What I want is to do the same thing inside my game. So I can copy. There is a function here to copy my point A and point B so that I can test directly inside the game. So if I go inside my code, how do I do that? So pathfinding is very easy to achieve. All you need to do is a class that we call A*query. A*query is a question, say, give me path from point A to point B. And then I define my point A, I define point B, I draw, I love drawing, that's very important. And when I initialize my query, I say compute, and when the computation is finished, I draw it, and that's all I need to do, and I can see my path directly inside the game. So once again, just to show you how it looks like when it's run from the game. Okay. Stop debugging, up. Yeah, and it's going to be quite fast, hopefully. It's clear. There you go. And now I'm going to hide my points. I don't need them anymore. There. So if I connect to my game, connect, I'm seeing that I have 2 points that I've defined inside the game, like this, and a point here, and I can see the path, and the path is computing inside my game, and I can debug using the navigation lab. So, of course, this is very easy. Very few calls and lines. That's very, very easy. So once you have this, you probably say, OK, my game needs entities. My game needs something interesting, please. And to make these entities, we provide you with a class. This is the class that you need to go for the A*query. We provide you with a class that we call a bot. A bot is simply an entity that will compute a path and that will follow it over time. So basically what I mean by that is the entity will tell you at each frame which velocity it has to go in order to move along the path. So if I do that in code, it's very easy too. So if I look inside my code, I created a new class. I'm going to call that my entity. And my entity is going to be a bot. And that bot is going to be added to my world. So I can use the first database for my world. And I can initialize it and add it to my database. And then each frame, I'm just going to expand this a little bit for you to see. Each frame, I can say, if you are arrived, you compute a new path for a new destination. And if you are arrived, you just swap the positions. And if not, you get the velocity from the bot. And that's it. It's finished. There's nothing more to it. So if I run this example, you are going to see that I have an entity. Let's run it now. My game is running. So now I want to connect to that game. So I'm going to clear that and connect to my game. And now, there we go. We have my entity going from point A to point B. So I can see now my entity is moving along my path. And I can record and debug everything as much as I want. Or I can reconnect and so on and so on. The good thing is, if you select the entity, you are going to get all the properties for your entity, like where does he want to go, where is his position, all the information about these entities, where is the target on path, and we provide you with more information about the algorithm Like, for example, our algorithm for this entity is following a target on the path, and I want to see that target. So I can select, and now, if you can see, I can follow that target, and you can see what the target is for the entity at each frame. This entity can perform shortcutting, right? But now, if you pay really careful attention, if I go back in time, and if I look at this entity here, go back in time, you can see now there is a problem. My entity is under the Nav Mesh. I don't want my entity to be under the Nav Mesh. This is not what I want. This is nice to follow the path, but I want the entity to stay on my Nav Mesh. I want the entity to avoid the walls. And the secret to do that is, as I said earlier, Nav Mesh physics. And to perform Nav Mesh physics, we provide you with a very easy tool to use. Let me just show you another example of this. So now I want my entity to stay on the Nav Mesh. So in order to do that, I'm going to use, it's exactly the same code, so there's nothing new, except at the end, I have a function called move on nav mesh, and if I look at that function, there, I'm going to use a specific query that we call move on nav mesh. This query is very useful because you say, I want to go, I'm in point A, and I want to go in that direction, and I want to stay on the nav mesh, and I want to collide with the wall. You can create the query, initialize it with your parameters, and compute, and it will tell you exactly what the right position for your entity is. And that's it. That's just as simple as this. And as you can see, even if there's some codes to test, because we do have lots of different states, that's as easy as this. So if I run this example now, like there, build and run. There you go. I have to stop debugging first. There. Yeah. So now if I rerun and connect, and I clear my debugger, my game is now running. And if I connect, I can see my entity is still the same, exactly the same code, so nothing new. But if I go here and wait for my entity to come, it should eventually at some point. You can see now that my entity stays on the nav mesh, and that is really cool, because now my entity is using nav mesh physics. So if I step in time, you can see the entity going up and down based on the slope. That's just as easy as this. So as you can see, the basic API for navigation is actually very simple. This is very simple, just simple calls, move on nav mesh, or create a bot, or compute a star, load the data. There's nothing very complex in that. It's very, very easy to do. So if you want to leverage the system, because we provide more systems that I'm just to give you an idea of all the things we can do for you. So for example, we provide, let me just clear that and disconnect my game. There. So now we provide you with ways to, for example, do avoidance. Like if you have many, many entities like this, and as you can see, as they walk, we want them to avoid each other. Because in some games, we want something like that. We provide you with obstacles avoidance. So if I create obstacles, like this, and if I'm not really nice, like this, another one here to there, and maybe a smaller one, like this. So you can see now that my entities can avoid my obstacles dynamically. That is actually fairly useful. So among all the other examples I can show you, as I said, we provide you with tools to expand your gameplay with very complex situations, like, for example, doors, kind of gameplay that you want to be able to manage, that automatic doors that opens and closed, the kind of gameplay situations that always happens, right? But you want the entity to behave. You want the entity to be able to go through the doors in a very smart fashion. Another example that is very common in the games, usually the ladder. Let me just show you that. Very common, very, very common in the games, right? It's kind of behavior. So as you can see, two different nav mesh, and the entities can follow a path, compute a path, use the ladder, and the path that is computed is annotated. So you can get the information directly inside the path, and you can use any animation or any smart behavior you want for your entity. And perhaps one of the most interesting features is our support for very strong physics systems. So, and very fast nav mesh, dynamic nav mesh. So if I create obstacles that are physics enabled, like this, and I give them some interesting size, like this, and if I spawn one, yeah, I'm going to hide my geometry. So hidden. So now, if I spawn an obstacle, as you can see, my nav mesh will automatically change based on where the obstacles spawn. But actually, our nav mesh, dynamic nav mesh system is incredibly fast. So as you can see now, the obstacles are going to stop, and the nav mesh will be re-updated at the same time. So if I have an entity that wants to go from one point to the other one, you can see now that it has to go through all the side around my set of obstacles. The reason why our dynamic nav mesh is so fast, it's because it's very local. We have what we call Nav Cells, and this enables you to only change what is required by the obstacles. So if you have your artist designing obstacles, for gameplay purposes, this is very cheap and very fast because it only impacts the area where the obstacle is. And it's dynamically updated. So for example, if I add obstacles on the path, you can see now my entity changed path, and at some point, maybe it will have to drop this path. Yes, and then, we have decided to go the other way around. So that's the kind of thing we can do. And as you can see, my laptop is not very fast, so you can imagine how it is in a real game. So, among the next step, of course, the next step of integration now is how do you generate the data inside your tools? Because you have your level designer have the tools, right? And they want to see the nav mesh inside the tool. So I'm not going to give you a live demo of that because that could be a little bit long. But the API calls is very easy. The only thing that we need to generate a nav mesh is triangles. So your artist creates the geometry for the level, and you give us the triangles. And this is done through the input producer. So you create your own coordinate system, and then you say, here goes all the triangles we have. Consume triangle from the position. So you give us all your triangles, and we generate the nav mesh. And once you have given us all the triangles, you can specify all those generation parameters, very easy, and you call generator generate. And the system will give you the nav mesh. That's it. Finish. That's quite easy. And then you can save the nav mesh in your file, or you can save into your own file, because this is a buffer. So you can do anything you want for the generation. As the last step, as the last example I'm going to give you today, because this is a very technical presentation, is how to generate all those obstacles. So to generate all those obstacles, that's fairly easy. So build. I'm going to hide this. The obstacles, to create an obstacle is fairly easy. So all I need is I create my class obstacle, and I say this is a box obstacle, for example, but you can have cylinder obstacles if you want. And I specify the size of my obstacle, and I can tell it, and then I can create it and add it to my world. That's it. When the obstacle move, when your gameplay makes the obstacle move, you simply update the obstacle in a way. So you can say the obstacle's new position is this, the obstacle velocity is this, angular velocity is this, or linear velocity is this. So you can change the obstacle's position. And one of the very important things is, if your obstacle doesn't move, you want the Nav Mesh to be updated. So that means that you want the obstacles, when the obstacle don't move, you want the Nav Mesh to be updated. And when the obstacle moves, you want dynamic avoidance. So this is supported with a very simple function call. Just simply say, does trigger volume, and then it will change the Nav Mesh or not. So if I run this example now, there you go, like this. So my game, still very simple and not very interesting, but now I'm going to connect to it. And where is my obstacle? Ah, there you go. So as you can see, I have an obstacle that moves because I give it a velocity. And when I want, at some point I say stop. And when the obstacle stops, the Nav Mesh is updated. And that is actually a fairly important way to manage the obstacles, because it means that you can leverage the best of both worlds. If you want to have avoidance in your game, you can use dynamic avoidance. And if you have static obstacles, you can use the static obstacles to really change the Nav Mesh and then to change the behaviors of your entities. So as you can see, the new API for navigation compared to Knaps, how many of you have used Knaps before? There is one there, I know him. No one else? But the new API we designed is very, very simple and very clean to use. And we provide you with this tool. This tool is your new best friend, so start to learn about it. It's very important. And this is a unique tool inside the whole industry, and it's given for free with navigation. So you have to use it. And we provide you with all the source code. So in terms of integration effort, if you really need to invest time into understanding how navigation works, you can always debug, even if there is something that you don't understand. So I would like to thank you for this session today, because I'm going to stop there. And I hope you like, and I hope it's given you an interest inside navigation. So please fill the review thingy, and I hope we'll hear from you. Do you have any question? There, question.
강의 잘 들었고요. 저희는 현재 지금
Hold on. Yeah, because I don't speak Korean yet. Thank you. So the translator is going to say it in English. Thank you. Okay. That's okay.
예, 저희는 지금 언리얼 3로 개발하고 있고 그 AI 미들웨어는 지금 그 그립 AI를 사용하고 있는데요. 근데 그 내비메시를 이제 생성시킬 때 그 언리얼에서 제공하는 기본 내비게이션 메시를 제너레이팅 하는데, 이게 이제 문제가 이제 그 의도치 않은 이제 그 메시들이 이제 내비메시가 생성이 되는데, 그거를 이제 언리얼에서는 그걸 편집을, 그 레벨 디자이너가 그 버텍스 단위로, 트라이앵글 단위로 편집을 하고 싶은데 그거를 편집을 못 해가지고 계속 그 블로킹 볼륨을 쌓고 또 다시 제너레이팅하고 또 잘못 나오면 또 다시 옮겨주고 제너레이팅하고, 그러니까 이게 무한 반복이 계속 되는데, 이쪽 그 내비게이션 이쪽 그 제품에서는 그 버텍스 단위로 이렇게 레벨 디자이너가 편집이 가능한지. 예.
Okay.
그게.
Okay, thank
감사합니다.
you. So, if I show you a nav mesh in navigation, just to show you a nav mesh like this. Start, yeah. What you see now, you think it's a nav mesh, but actually it's not a mesh. It's a connected graph. So each cell, this is a cell, is actually connected graph through each triangle. So it's not really a mesh. So it's not something that you can edit by hand. And that makes it, actually, you are very right. Most of the artists say, I want to edit the nav mesh by hand. But for us, the data structure, this is not a nav mesh. This is an A-star graph. So that's when I say I want to compute a path. So like this, if I run an A-star query and specify a point and that marker B, that marker B. So if I want to compute a path like this, I will know exactly which triangle I'm going to visit. So this is not a mesh. Let me show you in Unreal again a real case. Okay? Loading Unreal is very slow, so sorry. Okay. Okay. So let's take a real level. Yes, a real level. Like Unreal Tournament. Like this one maybe, yeah. Come on. Unreal is slow. There, real level, okay? The question is very important, right? Because if I generate a nav mesh like this, it's going to be very messy. So if I say, content browser, I want my world, this, like this, and set my world properties to use navigation. Okay. And now I want to create a JW nav. I want to create some nav data, unclean nav data. Drag and drop. There. Let's build. It's going to be a little bit slow because this map is not done for navigation. This is done for Unreal Tournament. There you go. And now I can look at the nav mesh. Where are you gone? Oh. Sorry. Why is my nav mesh gone? F4. Ah, there you go. So as you can see, I have nav mesh almost everywhere. But maybe this is not what the artist wanted, right? And then the artist will say, this is not the nav mesh I want, and I won't have to edit it by hand because this is going in places I don't want. Like here, for example, on the water. It makes no sense to have nav mesh on the water, right? It's silly. So the easiest tool for the artist, and probably the best way, is to use what we call the seed points, right? Because if I had a seed point, where are you gone now? Like, I select seed points and drag and drop only where I have the gameplay. There, and now I can regenerate. There. So now if I look downstairs, nav mesh is gone on the places where I don't want to. This accounts actually for 90% of the bugs. This is what the artists want. So they don't want the nav mesh in those places. So now, if you look carefully, the nav mesh is gone here too, right? And the artist will say, but I want the nav mesh here, because this is a place where the entity can jump. So I want the nav mesh there. So I can add more and more seed points. So if I show the if I select my content browser and say, I want another seed point, but I want this time, I want the seed points there, and regenerate. There you go. So as you can see now, my nav mesh is at the right place, right? Navigation generation is really fast, very fast, very fast. So it's very quickly that an artist can add all the seed points. And seed points is, just add seed points. You don't need to edit volumes or anything. You only use volumes when you have really precise control of the nav mesh. And this is the kind of workflow that we recommend. If you want the artist to edit the nav mesh by hand, it's, in the end, from what we have discovered talking with our customers, in the end, the artists are going to spend more time designing the nav mesh than making the gameplay. So that's what I think, yeah. Do you have any other questions? There.
MMOR
Yes, I need. Sorry.
MMORPG 서버에 내비메시를 적용을 하려고 할 때 보통 크게 이제 몇 가지들이 이제 좀 그러니까 마음에 걸리는 부분들이 있는데 첫 번째가 이제 멀티스레드 문제인데요. 요즘 대부분의 서버들이 이제 멀티스레드가 적용이 되고 있고, 그래서 그런 경우에 이제 내비메시가 보통 이제 그런 것들을 제대로 지원하지 않는 경우가 많아서, 그런 경우 이제 어떻게 처리가 되고 있는지가 궁금하고, 그리고 64비트 문제는 어떻게 또 처리가 되고 있는지 그게 또 궁금하고, 그리고 또 하나가 인스턴스 던전 같은 경우에는 보통 인스턴스 던전에서 보통 이제 같은 지역이 여러 개로 인스턴싱이 되게 되는데, 그런 경우는 이제 실제로 지형은 모두 다 같은데 거기에 올라가 있는 오브젝트랑 본만 다른 경우잖아요. 그런 경우에 어떻게 처리를 해야 되는지 뭐 그런 것들이 궁금합니다.
Yeah, I get it. So, very interesting question. Let's say I'm making an MMO, this very large world with lots of entities, and I'm concerned about the performance. Okay? Let's look at the performance directly inside the lab, right? And let's see all the contours and probably all the profiling issues, right? What you see here is the query performance cost. Navigation is multi-threaded, time-sliced, and you can use it in as many threads as you want. So if you have different sections of your game, different portions, areas, and you want to use different threads for each of those areas, you are free to do so. You can design any multi-threaded system around navigation. We provide you with a very clean API to say, I want to compute this pass on this thread, I want to compute this pass on this thread, I want to compute this, test, A star or recast on another thread, so you can balance your computation costs as much as you want. So we provide you with a system that enables you to say, navigation, I'd never want you to take more than 0.1 millisecond, for example. So you can say, set a limit, and each frame, navigation will only take the time you have given. This enables you for very fine grind control over the performance. And you always get all the information inside the lab. So navigation doesn't cheat. It will tell you exactly how much memory and how much time it takes. So that's for the first question. The other one is very interesting too, right? Because in some games, and we are going to see that later on, because they are doing exactly the same thing. In some games, you have different sections with different geometry. So where are you? Let's say, yes, I have this example. I'm going to show this solid, right? So in that scene, I have, for example, a castle here that is, built. And actually, I have two versions of the castle. I can hide this version. Hold on, where is? I need to generate first, so let me generate. There. There you go. I have two different versions of the castle. So I have the castle that is base, or I think, yeah. Yes. See? My castle now have two different types of geometry. And as you can see, the Nav Mesh actually is adapted for these two different types of geometry. So in your game, if you have different instances, you can use one or the other and still share most of the memory. So you can generate as many versions of the geometries that you want, as many versions of the same areas as you want. I'm not going to steal the same presentation because David is going to show us the same type of idea in Lord of the Rings, but with navigation you can really have alternate versions of your world. So you can build as many as you want. Is there any other questions, maybe, perhaps? Anyone? There? I'm sorry, I have to be careful about the time, right? You tell me. Okay.
질문이 많기는 한데 시간이 없을 것 같아서 두 가지 정도만 여쭤보겠습니다. 첫 번째는 만약에 인간이나 자동차나 탱크처럼 여러 가지 서로 다른 이동 방식이나 아니면 경사로에 따라서 똑같이 갈 수 있는 길이지만 갈 수 있거나 없거나 한 경우들, 그런 경우들에 대해서는 어떤 식으로 구현을 지원하고 계신지 알고 싶고요.
오케이.
그리고 스마트 오브젝트 관련해서 질문이 있는데, 스마트 오브젝트랑 실제 게임 엔진에서 쓰이는 게임 오브젝트랑 동일하지는 않을 거라서 그런 것들을 연결하고 툴에 저희가 필요한 기능들을 추가하고 하는 것들을 해야 될 텐데 그런 부분들의 변형이나 수정이 어느 정도 용이한지 알고 싶습니다.
Okay. So, first question. You have people like me, a little bit fat, but that's all right. And you generate the nav mesh for me, right? So my nav mesh is this. So now, let's say that I have different type of entities with different size. So what you can do is you can generate different type of nav mesh. So for instance, there I can change my radius, generate again, and you can see the nav mesh have changed a little bit. If I go even more big, like this, and now you can see that my nav mesh is really different because there's many places I cannot go anymore. Navigation.
질문을 하고 싶은 부분은요. GTA라든지 아니면 심시티처럼 길이 있을 때 사람이 갈 수 있는 길이 있고 차도가 있을 거잖아요. 네.
Yeah.
그리고 둘 다 갈 수 있는 길도 있을 거고요. 네, 그런 것들을
Yeah.
어떤 식으로 해서 처리를 할 수 있는지.
Yeah. So, we generate different nav mesh for different size. First thing. Second thing you can do is you can add what we call tag volumes. So a tag volume is a way to add information inside the nav mesh. And that's actually very powerful. So I can say, let's say, I'm going to add an area that is only for people. So let me launch that and say spawn a tag volume, tag Nav Mesh. So you can design and change your Nav Mesh like this. And now you can see my Nav Mesh has a different color, right? And I can do that in several places. I can add as much as I want. So like this. And maybe I have another area that is only for the car. So I'm going to add this information, like only for the car, like this. Tag Nav Mesh, tag volume. See? Only for the car. Or maybe I want this area to be only for, I don't know, rats or monsters or some kind. And then I can tag this area with this information. So then, when you have designed this kind of volumes, and you can give them any shape, so you are really free. So now, my Nav Mesh contains a lot of information, right? So when I'm going to compute a pass, I can say, when I'm computing a pass, I can say, this area is not for me, so I cannot go, and the pass will walk around. Or you can say, this area is good for me, and then I can go through it. So I think I have an example of this. Maybe this one, this type. In this example, I'm just going to edit this. You can see the two entities have been set up in a way that the green entity can only walk on the green, and this entity, the second one, can only walk on the orange area. Or you can design any type of mixed behavior that you want. That's very useful, very useful, and highly dynamic. So back to the second question, smart objects. Maybe this one. Yeah, let's take this one as an example. And I'm going to end because it's soon the end, all right? The smart object behavior that you want to design, the behavior of the object, this is your code. This is not my code. This is the game who decide the behavior of the smart object. I cannot decide for you how the smart objects behave. So we give you examples, like elevators. We give you an example that is free source code that you can use, but you can design any behavior you want. Any behavior you want. There is no limit. The only limit is your imagination, actually. So you can design anything you want as a behavior. And we provide you only examples. This is just samples. This is not API feature. This is example code. I'm afraid that we are going to get kicked out. So one last question.
네, 그 첫 번째 질문에 대한 보강 질문인데요. 네. 그 만약에 그 서로 차가 갈 수 있는 길과 인간이 갈 수 있는 길을 나눠 놓은 상태에서 지형에 대해서 그래픽 디자이너의 수정이 발생해서 다시 내비게이션 메시를 빌드하게 됐을 때 이전에 세팅해 놓은 값이 유지가 되나요? 아니면 다 날아가서 다시 세팅을 해야 되나요? 아니면 그걸 남길 수 있는 방법이 있는지.
So what I've shown you, the tag volumes, they are runtime. So you can change it anytime you want. Anytime you want. There is no problem whatsoever with that. So if your nav mesh change, the tag volume stays, and then the information is retained. And if the information, you want to change that information, you change it on the fly. There's no problem whatsoever with that, yeah. So I hope I answered all your questions. I'm sorry we have to flee. If you want, come and get me. I have my business cards, and I really would like to hear from your feedback. I hope you had an enjoyable afternoon, and I wish for you to get your feedback about navigation pretty soon. So thank you very much for your time. Thank you. Thank you.